Okay, we are moving on to Unit 11, Lesson 8, and now we are solving quadratic equations by graphing. Your objectives there? Let's go ahead and get started. Okay, when we graph a quadratic function, there are a lot of steps that are involved, okay? So if I'm looking here, step 1 says to write in the form ax squared plus bx plus c equals 0, okay? So that means that we have got to get 0 on a side by itself, if it's not already. Okay? Step 2 is after we have the quadratic equal to 0, we're going to write it in the same form as before, but just in y equals, which means we are essentially replacing replacing 0 with y. Okay? After we've done that, we will want to label what A, B, and C are, okay? So I'm going to want to actually write down my A number, my B number, and my C number, okay? So the A is the part that's attached in front of the x squared, so I'll just put whatever number that is. The B is the part that's in front of the x, and the C is just the constant part at the end, okay? Step 3 is to decide if the graph opens up or down. Step 4 is to find the vertex. Step 5, we're going to make a table of values. Okay, when we make our table of values, we're going to put the vertex in the middle of the table. Okay, and then we're going to pick a couple points on either side of it. All right, we need to make sure that we get 2 0 values for y. Okay, and we'll talk more about what that means when we do our actual graph here. Okay, then step 6, we're just going to plot the points we've come up with and connect them with a curve that forms a parabola. And again, a parabola is just a U-shaped graph. Okay, and then the last one is step 7. It says tell the coordinates where the graph crosses the x-axis. These are called the solutions. Another word for solutions that you'll need to know is roots of the equation. Okay, so we'll go ahead and jump right into this. Okay, so here we got the equation 2x squared plus 6x equals negative 4. Again, step 1 is to go ahead and make sure that we get this written into ax squared plus bx equals, or plus c equals 0. Okay, so that just means I need 0 on a side by itself. So I want to get 0 over here on the right, away from all this other stuff. Well, I can make 0 from negative 4 by adding 4 on both sides. So I'm going to just show that. I'm going to add 4 to both sides. Okay? Because negative 4 plus 4 equals 0. Then on the left side over here, I have no like terms. I can't combine x squareds and x's and 4's, so I'm just going to rewrite it all. Okay? So I'm going to go ahead and write that over here. So my form will be 2x squared plus 6x plus 4 equals 0. Okay? Now again, step 2 is to go ahead and replace 0 with y and write it into graphing format. Okay, so I like to flip it around. I like to put y first. So we're going to have y equals 2x squared plus 6x plus 4. Okay, then I want to go ahead and label a, b, and c. Okay, that makes it easier for my vertex work. So a is positive 2, b is positive 6, and c is positive 4. Okay? Now again, step 3 is I need to decide if this graph is going to open up or down, because that's just a good self-check to do for when we are have our graph at the end to make sure we did it correctly. Okay? Well, my a value is positive, so that means my graph is going to open upward because a is positive. Alright? Well, we know that step 4 should be to find the vertex of the graph. So my vertex, the x-coordinate, is the opposite of b all over 2a. Okay? So that means my x is the opposite of b, which is negative 6, all over 2 times a, which is 2 times 2. Okay, so that's negative 6 over 4, which is the same as negative 3 halves for the x value. Okay, now to find the y value of the vertex, I need to plug in my x value up here into that function to get y. Okay, so I'm going to put 2 times x, which is negative 3 halves, squared, plus 6 times x, which is negative 3 halves, plus 4. Okay? So I'm going to have 2 times, well, negative 3 halves squared is negative 3 halves times negative 3 halves, that's 9 fourths. Or 9 fourths. Plus 6 times negative 3 halves is negative 18 halves, okay, which is the same as negative 9, plus 4. Well, 2 times 9 fourths, that's 18 fourths, that's 9 halves. Okay, plus negative 9 plus 4 is negative 5. And 9 halves is the same as 4 and a half, so 4 and a half plus negative 5 is negative 1 half. Okay, so my vertex is negative 3 halves and negative 1 half. Okay? Now I have to fill in my table of values. So I'm going to go ahead and put x here, and then my function, y equals 2x squared plus 6x plus 4, and then my y, and we can also have my xy column out here. My vertex goes dead smack in the middle of this table because I'm going to put points around it. So I'm going to put negative 3 halves. I'm going to write it as negative 1 and a half just because. Okay, I'm not going to fill in all this middle section because I already did all that work over here and I don't want to do it again. Okay, and the y came out as negative 1 half. Now I need to pick points on either side of the vertex here. Okay, well, I want to count by even increments on each side every step that I go. Okay, so here the next number down that makes sense to me to make things easy to graph is to go to negative 2. Okay, because it's a half step down from negative 1 and a half. And you want to stay away from fractions as much as possible with these. Okay, well, if I go a half step down this way from negative 1 and a half, I have to go a half step up this way, which would put me at negative 1. Okay? Then on this side now, I can count by different increments that time. I don't have to go down a half again. I can just go to the next easy number, which would be negative 3. I just have to make sure that now I increased by 1 between these two, or decreased by 1, so I have to increase by 1 on those two. So that goes to 0. Okay, so notice again how my increments stay the same. I went down a half and up a half on the first level, and in the next level I went down 1, up 1. Okay, so that stays the same. Now, I'm going to save all the work on the rest of this, okay? You need to fill in all this work in here, okay? And fill in the y columns and get the ordered pairs out here. I'll help you out a ton here by putting in my negative 1 and a half and negative 1 half ordered pair there. Okay, and see what our 5 points are going to be for graphing. Okay, and then we're going to go ahead, I'm going to move on to the next slide, and we're going to go ahead and graph these. Okay, so now we're ready for the graphing part. This is what your table should look like right here. Okay, you should have had these points filled in already. These are the y's you should have gotten with the ordered pairs, and you should have a bunch of work in the middle here. Alright, so now I just need to go ahead and plot these points. Okay, now to make this slightly easier on myself for graphing purposes, okay, I am going to go ahead and stretch this out a little bit. Okay, I'm going to count by halves on this axis since I have some halves included. Okay, and I'm going to count by halves on this axis since there's some halves included. Now I can do that if my graph stretches all the way out. Well, if I count half, 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 half all the way up, I'm going to get to 5, which is still higher than my highest number. Same thing here, I'm going to get to 5 and negative 5 out here, which is still higher than my highest and lowest numbers. Okay, so that's what I'm going to do on my axis without labeling it here. So the first point I'm going to go ahead and plot is negative 3 and 4. Okay, so that's going to be at negative 1, 2, 3, and positive 4. 1, 2, 3, 4 will be right here since I'm counting by halves. Okay, then I'm going to go to negative 2, 0, and counting by halves, that will be right here. Okay, on the x-axis. Then I'm going to go to negative 3 halves and negative 1 half. Okay, so that's going to be right here. since I'm counting by halves. And then I'm going to go to negative 1, 0. And then I'm going to have a dot at 0, 4 up here. Now you can notice from my dots that these are curving upward, which is good because that's when I went and labeled my A value, which is positive 2. That said that I should trend upward, okay, with my graph. So it's going to open up. And notice you can see the U-ish shape here. So this is kind of an inexact science here. I'm just going to graph in a curvy line. Okay, now this is kind of difficult for me on my iPad, but I'm going to go ahead and just stick arrows up here at the top and just kind of curve my line down, not getting lower than the vertex, and then back up again. Whoops, kind of missed my dots, but you get the idea. Okay? Now when you do this, if you miss your dots, you should erase it and clean that up a little bit, okay, so that it connects the dots. But again, that's the idea. You're just curving it around, which is the nice thing about the curvy graphs. You don't need a ruler to make it exactly straight because they're not straight. Again, just things to pay attention to are to make sure that your graph does not go any lower than your vertex. It should connect with your vertex, but not get lower than that. Okay? So when my parabola opens upward like it does, my vertex is the lowest point. If it were a downward U shape, then my vertex would be the highest point on the graph. Okay? Now, one other thing to pay attention to here is it's going to ask you for the solutions of the equation. When you graph this, the solutions of the equation are going to be called the roots. Okay? And those are the points right here where we cross the x-axis. Okay, those are called, again, the roots, or the solutions to the equation. Okay, another word you'll see are the zeros. You should know all three of those. So if they ask you to find the zeros of the equation, that's right here. Because that's when, if I plugged in these numbers, okay, look at that ordered pair right there, that is my negative 2, 0. Okay. So my roots are negative 2, 0, and then negative 1, 0, where they cross the x-axis. So you can see why they are called zeros, because that's when my y value came out to be 0, is at these points. So the zeros are negative 2 and negative 1. Okay. Now, how do I write solutions for the equation for my roots? I just write that in x equals form. Okay, so my solution is x equals negative 2 and negative 1. Notice the difference between roots and solutions. Okay, roots are written as the ordered pairs where they cross the axis. Okay, the solutions are written as x equals and then the x coordinates. Okay, that's important to distinguish that difference. Okay, so make sure you understand that. If it asks for roots, it's asking for the ordered pair where it crosses the x-axis. If it asks for solutions, it's asking for what's the x value at that point. And this brings up an important teaching point here. Your parabola, when you draw it, has to cross the x-axis twice. Okay? Which means you should either see 0 in your table twice, or you should make sure that when you graph it, it crosses the x-axis. Okay, now if it crosses somewhere in the middle of a box here, then you're just going to kind of guess what that point is, especially if it's not in your table. Okay, it's nice when it works out in your table. It's easy to see right here what the solutions or roots are, because those are the zeros. Okay, but again, if it's not in your table, you just have to look at the graph and figure out where does it cross the x-axis. Okay, so if your graph does not cross the x-axis, you need to keep adding points on each side of your table until it crosses. So 1 point lower, 1 point higher, okay, and keep going until it crosses the x-axis. Because sometimes your graph might come down here, okay, and not cross for a while. Okay, so again, key point, make sure your graph crosses the x-axis twice. It has to do that to be able to get full credit and get it correct. So now we are going to go ahead and move on to the last problem. This is a word problem, so I know you guys will love it. Okay, so the problem says you shoot a basketball whose path is modeled by this equation. Okay, so you can see when you shoot the basketball here, it's going to go in a nice parabola trajectory, okay, a nice curvy motion, where x represents the time in seconds, and y represents the height of the ball in feet. Okay, so I'm going to go ahead and label that here. that my x is the time in seconds, and then my y is the height in feet. Okay? And we want to know what's the maximum height of the ball. Okay? Well, the maximum height of the ball is the same as the very top part of the parabola up here. Okay? Well, we can see that that's up here, kind of around this region. And we know that the point where that happens was called the vertex. Okay, so if they want us to find the maximum height of the ball, they're asking us to find out what the vertex is. So I need to be able to do that. So I'm going to go ahead and label my A is -1/9. Oops. And I need to know my B. My B is 4/3. Okay? So for problem number 1, I'm going to find the vertex, the opposite of B, all over 2 times A. Since we're in fraction form, I'm not going to write it as a fraction on top of a fraction. I'm going to write it as a division problem. Okay? So the opposite of B is -4/3. And I'm dividing that by 2 times A. 2 times A would be -2/9. Okay? Well, I know that when I divide fractions, I have to have some flippin' fun. So I'm going to change it to multiplying by the reciprocal. And this works out pretty nicely. We've got 3 and 1 and 2 and 1. And 2 times 3 is 6, and a negative times a negative is a positive. So my x value is 6. Then I need to figure out the y value. Again, I figure out the y value by plugging numbers into here and solving it out. Okay? So I've got to do -1/9 times x squared, and I'm going to do this, talk through it really fast just so we can get it. Well, I know 6 squared is 36, and 1/9 of that is 4, so that's going to be -4. Okay, plus 4/3 times 6, okay, is 8, and then plus 6. Well, -4 plus 8 is 4, plus 6 is 10. So my y value equals 10. Okay? Well, remember, this is asking me for the maximum height of the ball. Okay? Well, since I want the maximum height of the ball, that's this side, that's why it's important to label it. That's the y value of my vertex. So that's right here. The answer is 10 feet. Okay, so if I was actually playing basketball in a regulation 10-foot hoop, that would be kind of a line drive shot, or else it's not going to go in, because the rim is 10 feet tall. Okay, so it's probably not a very good trajectory in this case to be able to make the shot. Okay, number 2 asks how long will it take for the ball to hit the ground? Well, if it's asking how long for the ball to hit the ground, I have to think about what that means for the height of the ball. The height when it hits the ground is going to be 0. So I'm going to solve this by looking at my graph here and figuring out when does the height equal 0 in my seconds. Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, about 15 seconds to hit the ground. Okay? So in this case, hopefully we would not have a basketball shot that is modeled by this equation. Okay, because it only goes 10 feet high in the air and takes 15 seconds to hit the ground. That's physically pretty unrealistic. But that's what we get when we solve out for this equation. So whoever this person is right here has a very funky shot. Alright, and that is the end of this lesson. Hope you enjoy the graphing, and happy homeworking.